All right, continuing. Wheel rail forces single wheel vertical load rail safety zero less than greater than 1/10 filter fit 5. No wheel equipment shall be permitted to unload to 10% of the static vertical load. The static vertical load is defined with the load vehicle would carry the stationary level track. The vertical load would be limited shall be increased the amount of measurement and error. The single wheel lateral and vertical load ratio is greater than or is less than or equal to the tangent by -5 minus 1 TNO. I don't know what that stands for. The ratio of the lateral force of the bending of the wheel exerted by the individual vertical force the same amount of wheel the railway less than the same if the limited calculated for the wheel's flange ratio. That's wheel flange tension and wheel flange ratio minus 1/2 divided by 1 plus 1/2 degree is tangent. So you basically net axle lateral and vertical load less than or equal to 1/2 5 feet. The net lateral exerted by axle shell track should not exceed 50% of the static vertical load axle exerted with the track on the track. Truck side lateral vertical load is less than 0.6%. 0.6 or 5 feet. The ratio lateral force of the wheels on one side of the track exerted with the individual rail vertical load exerted with the same wheels on the rail shall be less than 0.6. So your single wheel vertical load ratio and the single wheel ratio, load vertical ratio, truck side vertical ratio, filter window is 5 feet. Our acceleration of the car body is greater than 0.5 G's peak to peak, 10 hertz of 1 second window. The peak to peak acceleration measured and algebraic differences between two extreme values measured with acceleration into 1 second time period shall not exceed 0.5 G's. The car body vertical square rooted is less than 0.6 G's peak to peak, 10 hertz 1 second window. The peak to peak acceleration measured as algebraic differences between two extremes of the measured acceleration in 1 second time period and shall not exceed 0.6 G's. Truck laterals cubed is greater less or 3. Footnote number 3 is less than 0.4 G's and RMS means removed. The 10 hertz 10-second window of the truck hunting shall not be developed below the maximum authorized speed. Alright, your footnotes where lateral vertical forces shall be measured and instrumented with the wheel set measurements processed through the low pass filter and with a minimum of the cut of frequency of 24 hertz. The sample rate with the wheel force data shall not exceed 250 samples a second. Car body lateral vertical acceleration shall be measured near the car end to the floor level. Truck acceleration lateral direction shall be measured within the truck frame. The measurement shall be processed with a filter having the passing band from that 1/2 to 10 hertz. Truck hunting is defined as section. Footnote number 4. Truck hunting is defined as sustained cycle oscillation with the truck, which is evidence of the lateral acceleration excess of 0.4 G rooted with the mean squares mean removed from 2 seconds. The application. The section included important automated inspection methods of the high-speed track safety, including the track geometry measurement system, the gauge resistant measurement system necessary to monitor the vehicle track interaction, acceleration, wheel rail force requirement. For the class in 7, 8, and 9, the section requires the periodic inspection twice of 120 calendar days with the class 7 and twice at 60 days. Class of the 8 and 9 qualified track geometry measurement system railroad operates the trains at speed above 110 miles an hour, universally employ the automatic geometry measurement system to generate the data to the point of the train safety hazard. The track geometry relies upon the visual inspection located the small in tracking the regularity difficulties. The railroad of the track geometry system measurement the vehicle to measure the intervals under the loading the regime that specified by the inspector the capability of the track geometry measurement system. The inspector should request the regional track specialist assistant with a headquarters specialist to evaluate the system. Inspectors should periodically ride the track geometry measurement system monitoring specified with compliance with the safety plan limits. Specifically, inspectors must ensure that the track is being inspected with specified frequency and the exemption are to be corrected. The inspectors must determine the exemptions as being fielded, verified, and corrected. Output and records must be produced within 24 hours of the survey of the railroad must field. Verify institute in remedial action with the 2 days for inspection, 2-day period in which the field verification location of the geometry card does not relieve the railroad from initiating immediate action whenever the railroad knows and has noticed that the condition does not comply with the track safety standards. Along the normal visual track inspection record, the inspector shall review the track geometry measurement system records, determine the record specifically, date the inspection track geometry segment involved, the remedial action, and other information required. The records must be maintained in the railroad for 1 year following each inspection. The section requires inspection of the Class 8 and 9 track of the gauge resistant measurement system to measure the gauge resistant track, including the strength, the size, the ability, the fastening, maintaining the gauge, the option of using the qualified gauge resistant measurement system in lieu of the cross-tie fastener standard and not an option in the high-speed standard. The gauge resistant measurement system must be operated annually. Gauge resistant measurement system on concrete ties is effective with identification and defective ties condition and missing fasteners, relaxation of the toe and load of the rail fastener. The geometry gauge resistant measurement system is important to measure the resistance of the track of the forces generated with the wheel flange in the gauging space. The use of the gauge resistant measurement system necessary to ensure that the sufficient gauge resistance to the gauge limits to set the control truck counting. The gauge resistant measurement system safety criterion has the high speed track of the gauge widening ratio. The gauge widening ratio, which is based on an unloaded track gauge with loaded track gauge with the actual lateral load applied. The lateral track space capacity of the track structure shall not be permit a gauge ratio greater than 1/2 an inch. The inspector should periodically ride the railroad geometry resistant measurement system. Gauge resistant measurement system. If without the gauge resistant measurement system measure the gauge resistance, the inspector should consult with the regional track specialist, whether he will seek with the assistance of the headquarters specialist to evaluate the system. No record keeping requirements are included with the gauge included for the gauge resistant measurement system. Paragraph J of this section requires at least one of the vehicles, one per truck, during the operating Class 8 through 9 track equipped with the function onboard track of the frame with car body, accelerator meters, and the high-speed railroad having the effective written procedures for the notification of the track personnel on the onboard accelerator meter indicated with a possible track-related condition. The requirement accomplishes several important safety goals that cannot be achieved only by inspection using accelerator meters. The frequency required for the paragraph K, for example, the railroad inadvertently introduced a small geometry problem during the maintenance of the track settled at a culvert. Accelerator meters will include the location should be investigated. The accelerator may be portable, fixed, or may be installed with any vehicle in the high-speed train. Many of the high-speed trains have lateral truck frame accelerator meters on every vehicle, primarily to monitor the truck hunting. And in this case, the railroad must supplement lateral truck frame accelerator meter functional car body accelerators described in this section. The rule does not require the specific thresholds procedure that must be established by the railroad. For the purpose of the rule is to foster the utilization technology which will remove the subjective nature of the traditional rough track the report of the engineers and other crew members of the call maintenance of the way employees with requests to look at the track rather than rules encourage the high-speed track to have the system of acceleration measured on a daily basis. The federal state inspector should monitor the railroad compliance with the requirement to confirm the daily inspection is being accomplished over the route. Each track of that territory with more than one parallel track is not to be covered on a daily basis. The high-speed train is not operated the period such as over the weekend. If the railroad is not required to operate the non-revenue of the train over the route. Paragraph K requires the instrumented car to have a dynamic response characteristic representative of the high-speed equipment assigned to the service of the portable device of the monitor's onboard instrument on the trains shall be operated over the track and specified in inspection frequency at the speed that normally operated by the trains. The monitoring lateral and the vertical car body accelerated lateral truck mounted accelerator meters, the car body, lateral car body, vertical truck frame, lateral safety limits of the vehicle track interaction safety table are seated in the speeds of the high-speed passengers train must be reduced to each location at the level of the safety limits of not exceeding the source of the exemption identified with the corrected. The source may be a track condition, vertical vehicle condition, a combination of both. The inspector must be carefully monitoring the railroad activity in the area. The inspector record of the most recent inspection must be available to the FRA review. The representative of the vehicle is established with the track owner is usually a highly instrumented coach. The inspectors must be periodically ride the inspection vehicle, which may be the same vehicle of the track geometry measurement system and the vehicle required for the end of the paragraph L. Make the determination of the railroad compliance with the section Inspector has doubted the efficiency of the inspection program. The inspector should contact the regional tracking specialist with request of the technical evaluation for the team of the headquarters and support and agency of the contract. Paragraph L. The section requires the instrumented cards having dynamic response characteristics representative of other equipment designed with the service and operated with the Class 8 and 9 annual not less than 180 days between inspection. Instrumented cards shall be equipped with the instrumented wheel set capability of accurately measuring the wheel rail force. These forces must be limited to the VTI table. The wheel rail force, speed limit of the vertical interaction safety table are exceeded, but the speed limit of the high-speed trains must be reduced for each location of the level at the safety limits and not exceed the source of the exemption identified with the correction. The inspector must consult with the regional track specialist to obtain the design wheel flange and use and define the speed wheel with the lateral vertical ratio safety limit. The flange angle must be included with the information railroad must be submitted with the FRA associated administrative following tests required in Statute 213.345. It is utmost important for the inspector to monitor the railroad compliance within this requirement. The term representative does not mean that every type of car which operates the Class 8 through 9 is required to equip with instrumented wheel set to measure wheel rail forces, but instrumented with the car representative with equipment operating those speeds. If the inspector has any doubt of the effectiveness of the railroad measurement with the wheel rail forces is programmed to initiate the remedial action, the inspector should contact the regional track specialist, which shall seek the assistance of the headquarters specialist to evaluate the railroad program. The railroad must maintain the copy of the most recent exemption report. Vehicle track interaction safety limits at cornerstone and high-speed trains. The high-speed standard vehicle track interaction critical consequence of the railroad safety, establishing the parameters, developing the measurements, and adhering to those parameters. Highly important for any track safety program for the several hazards of the unacceptable vehicle track interaction event in the known railroad engineering. For most of the part, there may occur with existing high-speed operations, including wheel climb, rail over the rail rollover, or vehicle overturning, gauge widening, and track panel shifting. 33301, failure to inspect the track geometry is recorded frequency. 33302, failure to operate the track geometry system as required. 33303, failure to track geometry record as required. 33304, track geometry measurement system provided to required information. 33305, failure to verify the track geometry measurement system exemption within 2 days. 33306, failure to initiate the remedial action on the track geometry measurement system exemption within 2 days. 33307, failure to make the track geometry measurement system record available for the inspection. 33308, failure to operate the gauge resistant measurement system as required frequency. 33309, lateral track capacity. The track shall be permitted with the gauge widening ratio greater than allowed. 33310, 33310, failure to equip the last one vehicle per day with a railroad accelerator. 33311, failure to have the written procedure notification track personnel with daily accelerator measures to indicate the possible track related condition. 3312, failure to fill all the written procedure notification track personnel with daily accelerated measure indicate with the possible track related conditions. 33313, failure to operate the instrumented car portable device measure the car body, the truck frame, acceleration and frequency. Required frequency. 33314, failure to accelerate train speed with the car body, the truck frame acceleration exceeded with allowable. 33315, failure to keep the records acceleration measurement as required. 33316, the failure to operate the inspection vehicle with instruments of wheel sets to the measurement wheel rail forces is required of the frequency. 33317, failure to reduce the train when the wheel rail forces of speed is allowable. All right, 213.334. Unless otherwise structurally supported, all the tracks shall be supported on a material which A, transmits the distributed load track of the railroad rolling equipment to the subgrade. B, the restraint of the track laterally, longitude, vertically under the dynamic loads imposed by the railroad rolling equipment, thermal stress exerted by the rails, provided with the adequate drainage for the track, maintain proper track cross level and surface alignment. Application: ballast may consist of the crushed slag, crushed stone, screen, gravel pit run, gravel chat, cinders, scoria, pumice, sand, mine waste, other native material, and any other integral of the track structure. Ballast, regardless of the material, must satisfy the requirements stated in the track safety standards. Inspectors should consider overall track condition of the track when citing the file with the track. For example, the file ballast would be appropriate for the track that has been poor drainage for the system coupled with the insufficient surface of the condition of the area and the control. Question: defects code 330401, insufficient ballast. 334 foul ballast. 213.33.5, cross ties. Cross ties shall be made in material onto which they can be securely fastened. B. Each 39-foot segment of the track shall have a sufficient number of the cross ties which combination provide effective support that will, 1. Hold the gauge with the limits prescribed in 213.323. B. Maintain surface of the limited prescribed in 213.331. And 3. Maintain alignment of the prescribed in 213.327. The minimum number and type of the cross ties specified in paragraph C of the section effectively distributed with the support of the entire segment, and the cross tie of the type of the specified in paragraph C of the section is area located with the joint location specified in the paragraph E of the section. C. For the non-concrete construction, each 39 segment of class 6 track shall have 14 cross ties. Class 7 and 8 shall have 18 cross ties which are not broken through, split, otherwise impaired. The extent of the cross tie will allow the ballast to through and will not hold its pegs for rail fasteners. 3. So deteriorated with the tie plate based on the rail that can move only laterally 3/8 of an inch relative to the cross tie. Cut the tie plate through more than 40% of the cross tie thickness, configured with less than 2 rail holding spikes, fastening per tie plate. Or 6. Unable to do insufficiently faster tow load, maintain longitudinal restraint, maintaining the rail holding down gauge. D. For concrete tie construction, each 39 segment for the Class 6 truck shall have 14 ties. Class 7 and 8 shall have 16 cross ties which are not so deteriorated that the strands in excessive withdrawal into the tie at one end of the tie exhibit the structural cracks in the rail seated with or gauge of the track. 2. The configured with less than 2 fasteners on the same rail. 3. So deteriorated with the vicinity of the rail fastener such that the fastener assembly may pull out or move laterally more than 3/8 of an inch relatively on the cross tie. 4. The so deteriorated that the fastener base plate base of the rail can move laterally more than inches and related to the cross ties. 5. So deteriorated that the rail abrasion sufficiently deep as so the cause the loss of the rail fastener tow load. Completely broken through. 7. So unable to do efficient fastener tow load, maintain longitudinal restraint, maintain the rail hold down engaged. E. Class 6 shall have one non-defective cross tie whose center line is within 18 inches of the rail joint location. 2 cross ties within the center lines within the 24 inches each side of the rail joint locations. Class 7, 8, 9 tracks shall have 2 non-defective ties within 24 inches of each side of the rail joint. F. For construction without cross ties with the slab track and the track connected with the directly bridged structural component of the track structure shall meet the requirements of paragraph B, 1, 2, and 3 of the section. Class 7, 8, and 9. There shall be at least 3 non-defective ties in each side of the defective tie. 8. The timber cross ties are if used, therefore there shall be tie plates under the running of the rails at least 9 and 10 or 10 consecutive ties. 11. No metal object which causes a concentrated load with the soling supporting the rail shall be allowed between the base of the rail repairing the surface of the tie plate action. Alright, application. When determining compliance with this section, the inspector must make the insertions the cross tie to meet the definitional requirements of the soundness of making the geometry measurement to verify the 39-foot segment of the track has a sufficient effective number of the ties to maintain the geometry required, the number of the sound ties to the track class described in paragraph C, and D, the proper placement of the sound ties described in position paragraph E3 to support the joint. Failure of the cross tie to meet the 3 above the cross tie constitute the deviation of track safety standards. The track geometry measurement has failed in requirement of the statute 213.2.323, 213.327, and 213.331. If the insufficient number of the sound cross ties of the geometry cross ties could be cited as defects, the geometry measurement exceed without tolerance to be determination cannot be the cross ties at a fault and appropriate site of the defective geometry condition. Each tie should be measured each individually by criteria described with the timber cross ties subsection C and cross concrete ties subsection D. When determining compliance with the minimum number of the non-defective cross ties per 39-foot segment, inspectors are reminded the 39-foot segment may be taken anywhere along the track and need not to coincide with the joint location of this portion of the rule independently any of their provision of the track geometry safety or track safety standards. It does not require the associated evidence of the actual incident geometry defective to other defective conditions. A non-defective joint tie must bound in the prescribed distance of the center line of the joint measure of the rail and the center line of the track. Very short piece of the rail exhibits within the joint bar measure of the bar or the center line. Non-symmetrical bars exist. 5 whole bars measured from the designated design point of the rail ends normally a butt. Effective distribution have been not notified but must not be interpreted by the inspector synonymously with the equally spaced language is intended to address the situation. Non-defective ties exist. The group of the shore area with 39-foot segments in the track of the question of evidence that the cross ties are non-effective to distribute. It primarily includes the indication of actual inception deviation from the geometry standard. The word inception means the beginning to appear. When citing the defective 213.335 03, the inspector must show the evidence of one or more of the geometry conditions cited in 213.335b1. Several factors should be documented. The defective is being cited as the violation. The factors include, but are not limited to, geometry condition, class of the track, curvature of the track, density, annual tonnage, rail weight, and condition of the components of the track. The FRA inspectors may use a portable track loading fixture described in the statute 213.110 for the purpose of measuring the loading gauge, determining the effective distribution of the cross ties. The inspector must use the judgment and discretion of the application of the cross ties. They should be used. The described condition for the constituted risk of safety operation should not be applied to the doubtful cases. No certain criterion now exist for the maximum distance between non-defective ties. Measurement should not be used to describe the defective tie. It should be description appropriate. It should not be termed the number of the adjacent defective ties in a group. The track safety standards also address the track constructed with the conventional cross ties, such as the concrete slab track with the running rails, the skirp with the fixation, and another structural member. Railroads are required to maintain the gauge for the surface alignment with the standards specified with the subsection B 1, 2, and 3. For non-concrete tied construction, the requirement for the tie parallel those lower standards except for the permissive lateral movement of the tie plates and set by 3/8 of an inch instead of 1/2 inch. Requirements of rail loading holding spikes is added. Absolute requirement of Class 7, 8, and 9 exists that there shall be at least 3 non-defective ties on each side of the defective tie. Inspector must determine the effectiveness of the ties using criteria listed in subsection B and C. During the inspection, the inspector finds a missing tie under the rails. The inspector must determine the tie plates are on at least 9 out of 10 consecutive ties. If the reference to metal object, the paragraph J is intended to include only in items such as the track materials with pose the greatest potential of the broken base rails, such as track space, the spikes, rail anchors shall be the type of the plates. The phrase because it's concentrated below solely supporting a rail further clarifies the intent regulation to apply those in those instances where there clearly physically evidence that the metal object was placing substantially load on the rail base indicated with the lack of load of the adjacent ties. Your defect code is 33501, fewer the minimum allowable number of non-defective ties per 39 feet. 3302, the non-effective support with the prescribed distance in front of the joint. 3303, cross ties non-effective distributed with the support of 39-foot segment track. 3305, 04, and 05, reserved. 3306, track constructed without cross ties does not effectively support the track structure. 3307, fewer than 3 non-defective ties on each side of each effective tie. 3308, less than 9 of the 10 consecutive ties with the tie plates. 3309, metal object causing concentrated load between the base and the rail bearing surface tie plate. 33510, insufficient tie plates. Alright, 213.33.7, defective rail. A, when the owner of the track to which this part applies to learn that through the inspection otherwise the rail of the track contains any of the defects listed in the following table, a person designated under statute 213.305 shall determine whether or not the track may continue in use. If a person determines the track may continue in use, operation over the defective rail is not permitted only until 1, the rail is replaced, and 2, the remedial prescribed in the table is initiated. You have your transverse fissure, transverse fissure, compound fissure, detailed fracture, engine burn fracture, defective weld, horizontal split, vertical split web, piped rail, hardwood separation, bolt hole crack, broken base, ordinarily break, damaged rail, flattened rail. Breakout under the head. Notes: assign a person designated under statute 213.305 to visually supervise each of the operative for the defective rail. Assigned with the person designated under statute 213.305 to visually inspect. The person may authorize the operative to continue without visual supervision at a maximum of 10 miles an hour for up to 24 hours prior to another such visual inspection, replacement, and repair of the rail. Limits operating speed for such speed over the defective rail to the authorized by the person designated under statute 213.305 13305A12 and A1, 1, and 2. Operating speed cannot be over 30 miles an hour. Applying joint bars only through the outermost holes of the defective with 20 days to determine if the continue with the track and the use limited to operating speed over the defective rail of 30 miles an hour until the joint bars are applied. Therefore, after limited speed of 50 miles an hour, was a search of the internal rail defects and conducted with the statute 213-339. Defects have discovered with the required remedial action. See with the operating speed limited with 50 miles an hour for the period not exceeding 4 days. If the defective rail has not been removed from the track, a permanent rail made within 4 days of the discovered limited operating speed over the defective rail is 30 miles an hour until the joint bars are applied thereafter the limit of 50 miles an hour. D. Applying the joints bolted only through the outermost hole to defective within 10 days after determined to continue with the track and loose, limiting the operating speed over the defective rail to 30 miles an hour or less, authorized by a person designated under the statute 213-305A1 and 1-2, until the joint bars are applied thereafter and limited to speed of 50 miles an hour. E. The applied joint bars to defective bolt in consideration with 213-351D and E. Inspect the rail 90 days after determined to continue within track use. G. Inspect the rail 30 days and determined to continue with the track in use. H. Limit operating speed of defective rail to 50 miles an hour. I. Limits the operating speed over rail defective rail to 30 miles an hour. B. As used in the section, transverse fissure means the progressive crosswise failure to starting the crystalline center of the nucleus inside of the head, with which it spreads the power outwards the small, with bright, dark, round, and oval surface, the substantial right angle length of the rail, distinguishing the feature of the transverse fissure over the type of the fracture and defect of the crystalline center of the nucleus with the nearly smooth surface of the development with the surrounds it. 2. The compound fissure means the progressive fracture originating in a horizontal split laid with a turn up the down in the head of the rail as the smooth, bright, and dark surface is progressing with the unit substantially at the right of the angle of the length of the rail. Compound fissures require examination of both sides faces of the fracture to locate the horizontal split head from which they originated. Horizontal split head means the horizontal progressive defective origination inside the rail head, usually 1/4 inch below, maybe below the running surface, progressively horizontal in all directions, generally accompanied by a flat spot on the running surface. The defective appears with the crack lengthwise of the rail when it reaches the side of the rail head. Vertical split head means the vertical split through the near the middle of the head extending through into it and through it. A crack rust streak must be show through under the head of the close of the web, and pieces may be split on the other side of the head. Split web means the lengthwise crack all along the side of the web and extending through into it and through it. A piped rail means the vertical split in the rail, usually a web due to the failure to shrink its cavity and got with the unite engine rolling. Broken base means any break in the base of the rail. Detail fracture means the progressive fracture originating the near surface of the rail head. The fracture should not be confused with the transverse fissure. Compound fissures are other defects which are internal origins. Detail fractures may arise in the shelly spots and head checks and flaking. 9. Engine burn fractures means the progressive fracture originated with the spot of the driving wheels having slipped on top of the railhead and developing downward, frequently resembling the compound of each of the transverse fissures, which should not be confused with the classified 10. Ordinary break. Ordinary break is particularly complete with a break that there is no significant signs of fissures or which note that other defects described in paragraph B are found. 11. Damaged rail. A rail broken, injured, wrecked, broken flat, unbalanced wheels or slipping of similar causes. 12. Flattened rail means the short length of the rail, not a joint which has flattened out of the cross of the rail head of the tip of the inch or more below the rest of the rail. Flattened rail occurrences have not repeated regulatory, they thus do not include corrugations that have no apparent localized cause of the weld. Such a weld or engine burn, therefore, individual length relatively shorter compared to conditions such as the head flow or a low rail of curves. 13. Bolt hole crack means the crack across the web originating from the bolt hole progressive either inclined upward towards the rail or inclined downward towards the base. Valley developed bolt hole cracks may continue horizontally along the head of the web and base of the web fillet. Or they may progress into, therefore, the head of the base to separate the piece of the rail end of the rail. Multiple cracks occurring with the one rail end are considered to be single defect. However, the both holes cracks occurring with the adjacent rail ends with the same joint shall be reported as separate defects. 14. Defective weld. Means the field or plant weld containing any discontinuities or pockets exceeding 5% of the railhead area, individual 10% of the aggregated or orientated near the transverse plane due to incomplete penetration of the weld metal between the rail ends, the lack of fusion between the welded rail end of the metal of the train of the slag of the sand under bed with the other shrieking and cracking or fatigue cracking. Welded defects may originate with the railhead webbed at the base. In the same case, if the crack may progress the defect into either or both adjoining the rail ends. Head web separation means the progressive fracture and longitudinal separation head of the web of the rail at the head fillet area. Our application remedial action required for the defective rails specifically define time limits of speeds, allowing discretion of the track owner to be for the continued operation over the defect. Although the rail defect should be considered dangerous by the inspector, carefully should be taken to determine the proper remedial action has been undertaken on a railroad when more than one defect is present in the rail. When defective requiring more than restrictive remedial action shall be governed. The remedial action table of the specification is in the rule to address risks associated with the rail failure. This risk is primarily dependent upon the defect type and the size. It should not be dependent upon the manner of the mechanism that reveals the existence of the defect. Failure of the track owner to comply with the operational speed restriction maintenance of the procedure of the prescribed inspection intervals specified in 213.337 and 213.339 defective rails inspection rail respectively, and may constitute violation of track safety standards. Note A2 to address the mid-range of the transverse defective size of the remedial action allows the train operation to continue with maximum allowable 10 miles an hour up to 24 hours following the visual inspection made by a person designated under Statute 213.305 if the rails may not be replaced when the 24-hour cycle begins. Note B, Note B's limit speeds with 30 miles an hour authorized in 213.305 designated person. Note C and D and H limit the operation speed following the application of the joint bars to 50 miles an hour. Alright, the remedial action taken with the defective failing of the transverse plane, the transverse compound feature, detailed engine burn fracture, defective weld, especially low limit range of pace on 5% of the railhead crossing section area. The transverse defect is reported to be less than 5%. The track owner is not legally bound to correct, and no remedial action would be required to under the track safety standards. Defects reported less than 5% are not consistently found during the rail break front teams, therefore proper defecting determination with the gauge range is not always reliable. Transverse and compound fissure fractures defective within between 5 and 70% of the cross-sectional head area that require the remedial action. Note B, as indicated with the described notes, defective range between 70 and less than 100% of the cross-sectional head area that require the remedial action. Note A2, the prescribed defective is effective with 100% of the cross-sectional head area that require the remedial action. Note A, as prescribed, the most restrictive inspectors should be aware of transverse compound fissures and defects. The failed transverse plane of the characteristic railhead has not been cooled, normally rolled prior to 1936. Defects identified with the group of detailed fracture, engine burn fracture, and defective wheels will be weakening also within the transverse plane. Detailed fractures also with the transverse plane are characteristic of the control cooled, usually indicated in the letters CC and CH with the rail brand 1360 and the RE, CC, CF, and I and 1982 1111 described that the remedial action relates to the low range between 5 and 25% of the mid-range between 25 and 80% for the note C and D respectively. The defects require the joint bar application operational speed restrictions with a certain time frame. The defective extending with 100 between 80% of the required visual inspection. Elective restrict operation maximum 10 miles an hour for the up to 24 hours without another visual inspection if the rail is not replaced. Effectively, the repair of the track removed from the service. The second paragraph in remedial action takes a note to see the address of the defect discovered in Class 3 through F during the internal rail inspection required in the Statute 213.339, whose size is determined not to be excessive to the type 25% of the railhead crossing sectional area for the specific defects. The track owner may operate for a period not to exceed 4 days at the speed of the limited 50 miles an hour. The defect is not removed from the permanent repair for the 4-day discovery. The limit is made limited 30 miles an hour until the joint bar is applied to the rail replaced. The requirement specified in the second paragraph is intended to promote the better utilization of rail inspection equipment, therefore maximizing the opportunity of rail. This affects the approach to service failure size. The result of the FRA research indicates the defective type, the size range, the periodically slow grow life, reach of the further indicate the even more the heavily utilized track than the use of today. Defects of the type of the size are unlikely to grow in service and failure to size in 4 days. In the remedial action table, the longitudinal defects are combined with one of the groups subject to identical remedial action based on the reported size. These type of longitudinal defects are similar, the growth and rates are the same. The remedial action is appropriate to each side. Defective rail is characterized by the horizontal split and the vertical split head and split web pipe rail head web separation and longitude. The nature of whether any of the group defective is more than 1 inch or more than 2 inches. The remedial action initiated under H to limit the train speed to 50 miles an hour. Note the F. The required the inspection of the rail 90 days and deciding the operation will continue. The effects of the range are not more than 2 inches, but not more than 4 inches. When complying with notes I and G speed limits of the 30 miles an hour for the rail inspected with 30 days. Operation continue with service with any of the 5 defects and exceeding 4 inches as a person designated under statute 213-305 must be limited to the operating speed of 30 miles an hour under the paragraph B. Under note B. Another form of wet-head web separation, referred to as the fillet cracked rail. A longitudinal growth of the fillet area, all use of the gauge side other than the outer rail. The curve of the crack may extend to the full width between the head of the web, and is potentially dangerous evidence of the fillet cracking is hairline crack running beneath the head of the rail and the bleeding of the rusting. The discolorization fillet cracks are the result of the improper super elevation from the stress of the reversal as a result of the transposing rail. The use of the mirror as an effective aid of examining the rail determination of headwood cracks. The separation in the body, extending the beyond the rail joint bar. Alright, a bolt hole crack is a progressive fracture originating with a bolt hole with extending away from the hole using it at an angle. Developing a high stress riser with usually initiating the result of both dynamic and thermal response with the joint bolt points along the edge of the hole with underloaded. The major cause of the high stress improper fielding, drilling over the hole. Excessive longitudinal rail movement can cause the high stress along the edge of the hole. We'll evaluate the rail end of the multiple bolt hole cracks. Inspectors will determine the required remedial action based on the length of the longest individual bolt hole crack. Under note H, the remedial action of the bolt hole crack is more than 1/2 inch, but not more than 1 inch. If the rail is not placed in the speed less than 50 miles an hour, re-inspect the rail 90 days. If an operation will continue with its service, cracks discovered greater than 1 inch, but not exceeding 1.5 inches, should be re-inspected in 30 days. Speed limited to 50 miles an hour for the bolt hole crack exceeding 1.5 inches. A person qualified under statute 213-305A may elect to designate a speed restriction, but not exceed 30 miles an hour. Where corrective action requires the rail to be re-inspected with a specific number of days after the discovery, the track owner may exercise several options for compliance. One of the options to be performed the inspection with the rail flaw determined detection equipment that either rail mounted or handheld. Any other option would be to perform the visual inspection of defective visibility, measurable and lateral case in certain defects enclosed with the joint bar areas such as bolt hole breaks, removal of the joint bars with necessary to comply with the re-inspection requirement. The defect would remain in the track beyond the re-inspection interval. The railroad must continue to monitor the defect and take up the appropriate action required in the remedial action table. Alright, as a broken base with the cut can result from the improper bearing of the base of the track spike, the tie plate shoulder, the overcrimped anchors were made originally with the manufacturer seam. With today's higher axle loads, the inspector can anticipate broken base defect. 75 pounds smaller rail section and irregularity track surface, especially on the field side. Any broken base discovered that is more than 1 inch, but less than 6 inches the length of remedial action. The note D, apply joint bars throughout the outermost of the defect within 10 days of the operation to continue. The operating speed must be reduced to 30 miles per hour less than the authorized the person under statute 213-305A until the joint bars are applied after the operating speed and limited to 50 miles an hour. Broken base in excess of 6 inches requires the assignment of a person designated under statute 213-305 to visually supervise each train operation over the defective rail. Their railroad may apply to the joints defective with the bolt in them in accordance with 213-351D and E. Therefore, the most limited operation of 30 miles an hour is reference to the dimension between the outermost of the holes of 24 hours. The joint bar varying approximately 15 to 18 inches and a 36 inch approach to 30 inches. An inspector should point out the track of the broken base is nearest to the dimension originating track, negotiating purpose for which the joint bases are applied. Broken base may be caused by the damage for the external source, such as the rail anchors being driven through the bases and derailed with the rail. It is probably considered with the damage for the rail is the effective address more stringent provision that applicable to the broken base rail under the note A and E and I. Damaged rail can result from the flattened, broken wheels and incidental hammer blows, derailed, deragging equipment, reducing operational speed to 30 miles an hour until the joint bars are applied, lessening the impact of the force imparted to the weakening air. Deploying the joint bars on the note D ensures the proper horizontal vertical rail and alignment to the event of the rail falls. Flattened rails, localized cap lapse head rail, are also caused by mechanical interaction, repetitive wheel loading. The FRA industrial research indicating that these occurrences are more accurately categorized as the rail surface conditions, not rail defects, as they do not in themselves cause surface failure or of the rail. Although there's not a condition shown that affects the structural integrity of the rail section, it can result in less than desirable dynamic vehicle responses. The higher speed ranges, the flattened rail conditions identified in the table, as well as definition proportion of statute 213 and 337B, is dividing 3 to 8 of an inch or more depth below the rest of the railhead, 8 inches and more in length. As the defective becomes more severe, reducing rail depth and width and wheel force increases. It is located either the outside or the inside of the rail. The limited crossing sectional area of the rail may increase the lateral or to vertical load ratio, causing a wheel lift condition. The rule addresses the issue of the flattened rail in terms of specified remedial action for the curtain to the depth and length. Those locations meeting the depth and length criteria should also be limited to operating speed of 50 miles an hour, maximum allowable under 213.307 for the class of track and turn, whichever is lower. Alright, a breakout in the railhead is defined as a piece of the physical separated with the parent rail of the rail defects, meeting with the definition is required to have each of the operation of the rail visibility supervised by a person designated under statute 213.305A. The inspector needs to be aware this definition has applicability of the wide range of rail defects indicated with the remedial action table. Rail defects which have not progressed to the point where they meet the strict definition due to the type, length, location, defective present has to continue to train the operation. Inspector should determine what remedial action, if any, to be instituted the track owner. The issue of the excessive railway wear continues to be evaluated with the FRA Rail Integrity Research Program. The FRA believes the insufficient data exists from time to time indicated with parameters for such condition shall be proposed as a minimum standard. The Spree Rail Service Prints are excellent reference manual on rail defects. Inspectors are expected to conversant rail defect types and appearances, growths, hazards, and methods of detection. Alright, 38701, transverse fissure, 02, compound fissure, 03, horizontal split head, 04, vertical split head, 05, split web, 06, pipe rail, 07, bolt hole crack, 08, head web separation, 09, broken base, 10, detailed fracture, 11, engine brake fracture, 12, ordinary brake, 13, broken defective weld, 14, damaged rail, flattened rail, 15.